about supervised contrastive learning. First of all, we have to install TensorFlow and TensorFlow add-ons, and then we are the checking our version over here, and then we importing the corresponding libraries. We have given seed 42, so it creates the random seeds here, and here we have taken as data that is fashion MNIST, and then we check the logs. We first loaded the MNIST data, and we did multi-class n-pair loss. We trained the encoder with the multi-class n-pair loss, and then we checked the learned embedding, and we got the scatter plot like this. And for the fashion MNIST, we have done the embeddings, contrastive normed, and fashion MNIST. And the stage 2 is a freeze the learned representations and then classify learner on a linear layer using a softmax loss. And we have done supervised NTX next over here, and checked the learned embedding and plotted the scatter plot. Yeah, and the second one is transfer learning on various modalities. First of all, we are doing it on images. First of all, we have done CIFART and data. So it is a cat versus dog dataset. So we first use only 3 classes, cat and 5 dog, and then we trained over it and renamed and normalized, and binary labels we have given cat as 0 and 0 as 1, and feature extract and compile, and we did training on the dataset and getting the predictions. And then we performed same with the audios and videos as well, and the zero transfer zero shot classification using clip. First of all, we are importing all this here, and transfer learning using the TensorFlow, and we have run 5 epochs with the entire dataset. First of all, we have taken the MNIST dataset, and we have trained this dataset over with efficient net b3. Also, we have plotted the sites over here, and then we are coming to fashion MNIST. First of all, we configured and split the data, created the data loader over here. Here you can see how in the fashion MNIST, these are the images available, and we are building the model over here, and then we have given the inference model, and here we have plotted the results. We got the 90% accuracy. And the third one is transfer learning with hub. So we have a classifier model pre-trained, image and benchmark dataset, no initial training required. So we have run it on the single image and simple transform learning we did, and run the classifier on a batch of images, and download the headerless model, attach a classification head, train the model, and check the predictions, export and reload your model over here. And coming to CIFART and Keras, simple example of the efficient video for a CIFART dataset we did over here, and we did training using efficient net v3. And the next one is X-ray phenomena classification. So here we have pneumonia classification of lungs over here. And here is a CT scan 3D image classification. First of all, we are importing necessary modules and packages, and then we downloading the mosaic dataset, which consists of lung CT scans with COVID-19 related findings, and we have loaded and pre-processed the data. Also, we read the parts of CT scan from class direction and building training and validation data sets, and then we did data augmentation by flipping, reversing, or moving around the image, and also visualize the augmented CT scan. Here you can see this. This is the augmented CT scan of the brain. So here you can see. Also defining 3D convolutional neural network for this and training the model. Also visualizing the model performance over here. Now we are fine tuning the convex native for convolution next mu to v2 for image classification. First of all, we are loading the dataset, and then image classification usually contain 2 things: images and corresponding labels. So here are these, and labels are present as integers, but we turn them into actual names as follows. Also, we pre-process the dataset, Also we define the model and train the model and pushing to the hub inference, and we have done the PMPI pipeline, and coming to last one, MLP mixer, we loaded the data, trained the model. We have taken the flower photos data set over here, and then we trained the model and predicted the model. Thank you.